And I suppose you can see why there might have been some debate, because from here the Earth certainly looks flat. Now, everybody knows that it's round, but how do you know? You know because someone told you. And I suppose if you really think that seeing is believing, then you would have had to wait until we left our planet, journeyed off into space, turned around and took a picture to see our beautiful spherical Earth in all its glory.
This is the first ever photograph taken from space of the Earth, fully illuminated by the sun. Taken in 1972 by the Apollo 17 astronauts as they travelled to the moon, it became the most viewed image in history and was named the Blue Marble. This shape is echoed throughout the universe. Look at every star and every planet and you'll see that the sphere is dominant. And it's all because of gravity, the same thing that keeps our feet firmly rooted to the floor. With gravity, the bigger the mass, the stronger the attraction.
Now, I'm not very massive compared to a planet, and neither is this pier. So the gravitational force that this rock feels is overwhelmingly dominated by the Earth. And so when I drop it, it falls directly towards the centre of the Earth. And that's the reason that planets are the shape that they are.
It's because gravity attracts everything towards the centre of a planet that they form as spheres.
In the early days of the life of the solar system, our young sun was surrounded by lots of dust and rocks, but some pieces of rock were bigger than others, and that meant that they had slightly stronger gravity, so they attracted more and more smaller pieces to them, and they grew and they became bigger and bigger and bigger.
And over tens of millions of years, these bodies grew so big that they eventually became planets.
Now, gravity doesn't have a preferred direction. It doesn't care whether it pulls things in from over there, over here, over here, over here. So what kind of shape will gravity tend to form? Well, it's not going to form an irregular shape like this, because gravity doesn't care about direction. It will form a shape that doesn't care about direction either. Now, the only shape in nature that looks the same from every direction is a sphere.
It's the most symmetrical shape in the universe, and that's why you see it everywhere. Now, it's not easy to mould solid rock into a sphere, but gravity gives planets a helping hand to form that perfect shape.
Now imagine this is one of those small pieces of rock falling towards the young, ever-growing Earth. Now when it hits the ground, it delivers energy to it. You hear some of that as sound, but some of it also goes into heat. Now imagine, over millions and millions of years as the Earth grows, how many millions and millions of pieces of rock smash into the Earth and make it grow. They deliver a huge amount of energy to the Earth.
And all that energy made the centre of our planet get so hot that it melted its solid core, making it even easier for the sphere to form. And incredibly, some of that heat is still escaping today, helping to fuel volcanoes across the Earth's surface. Gravity is the reason that our planet is spherical, but it doesn't always win out. Not everything in space is quite as perfect.
So spheres are fickle things. They only form over a certain size. And the rocks and pebbles on these beaches all have their own gravity, but it's far too weak to reshape the structure of the rocks into spheres. So just like these beaches, the solar system is littered with odd-shaped rejects.
At 27 kilometres across, Mars's moon Phobos is so tiny it looks more like a potato than a planet. And covered in craters, the strangest of them all is Saturn's sponge-like moon Hyperion, which looks unlike anything else in the solar system. On average, moons must reach about 500 kilometres in size before they have enough mass for their gravity to shape them into a sphere.
The solar system is a world of spheres, but there are plenty of places out there that never quite made it. And it's quite a thought to think that if our Earth had been much smaller, then gravity would not have been strong enough to sculpt it into that beautiful, perfect blue marble that we see hanging against the blackness of space.